This slide expresses the Euclidean algorithm in the form of a pseudocode formally. So what happens here in this algorithm is that we have two input numbers a and b for which we want to find the greatest common divisor, and we assume that both of them are positive integers, and we initialize local variables x and y with the starting values of a and b. Okay, and then we update these values x and y to smaller and smaller values for which it is easy to find the greatest common divisor. So we run a loop until the smaller of the two numbers, which is y, becomes 0. Okay, we keep on running this loop until y becomes 0. And every time this loop runs, we find the remainder of x modulo y. By the remainder that is obtained by dividing the bigger number, for example, to start with a and b, and we call this remainder as r. And then we reassign x and y in such a way that the bigger number is updated to be the smaller number, and the smaller number is updated to be the remainder. Okay, and at the end of the day, when y becomes 0, then we take the smaller of the two numbers, which in this case is x, is the GCD of a and b. Okay, just like in the previous example, initially the GCD that we wanted to find was for 287 and 91, and in the next iteration the value of x was updated from 287 to 91, and the value of y was updated to the remainder, which was 14. And in the next iteration, 14 took the place of 91 and 7 took the place of y. And the next step, the remainder turned out to be 0. So we have y equals 0, but x turned out to be 7. Okay, and this x equals 7 becomes the GCD of 287 and 91.